Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is type shortcuts where the type comes from initialization. Before proceeding, make sure that you have already watched these other videos first. Traditionally, the programmer needed to specify a variable's data type, in this case int, when he defines the variable. But this variable is being initialized at the same time as it is being defined. And every sub-expression in C++ also has some data type. That includes this literal sub-expression of 11. This literal's type is also int. So in a sense, we're being a little bit redundant here. And in C++11, we could skip that redundancy by using the keyword auto, instead of manually writing out the int type name. When we use this shortcut, the compiler will infer what we wanted, was Ivar's variable type to be int because that's the type of the initialization data. This usage of the auto keyword replaces some other unrelated, obsolete meaning of auto that used to exist in the C programming language. The right-hand side of this example dynamically allocates an int and initializes it to some value. Again, we can use the auto type shortcut here, inferring its int type from the 123 value. If we use auto on the left-hand side, the compiler will correctly infer that the PI pointer variable's type should be pointer to int. Or an auto type shortcut can be modified by adding things like the star or ampersand symbols to manually force that part of a type name specification. So this will have the same result. Here the programmer has specified pointer to something, and then the compiler has inferred it to be pointer to int. When deciding how to interpret auto, the compiler chooses the most simple type possible. We might incorrectly think that we could replace this reference to int by the auto keyword, but that wouldn't work as we expected, because int is simpler than reference to int. And this code's syntax would be valid if that auto became only just int. So in this case, if we had really wanted it to be referenced to int, we would have needed to write auto ampersand, or write out the whole type name as int ampersand. Likewise, in this case, the syntax would be valid either way if we had wanted this programming to define a constant int I auto b or just an ordinary int I auto b. So the type shortcut chooses the more simple option. And so this I auto b is not a constant. The compiler's decision making is not influenced by the fact that the right-hand side initialization value is using a constant variable. Indirection to that constant variable doesn't change anything. But if the auto type shortcut determines that we need a pointer to something and that something is a constant target, then this inferred type has no other choice but to be a pointer to constant int. Remember that an ordinary reference is not allowed to refer to a constant variable, but a constant reference is allowed to. Consequently, when you use this type shortcut, the compiler will need to make it a constant reference to int. Recall from one of our other videos that a R-value reference is a new type that acts somewhat like a traditional L-value reference, but it's programmed using two ampersand symbols to make it distinguishable from an L-value reference. The purpose of an R-value reference was to indicate that something either is an R-value, such as compiler temporaries, or should be treated as an R-value, in the sense that we want move semantics to efficiently move a data payload out of an object. Whenever this auto type shortcut is programmed with two ampersand symbols, the compiler will look at the type of the initialization value. In this case, that initialization value is an R value. Therefore, the type shortcut is the same as if you had programmed an R value reference to int. But if the initialization value had been an L value, such as this ordinary variable, then that type shortcut is the same as if you had programmed an ordinary traditional L value reference to int. By the way, these happen to be the same deduction rules that template specialization uses for its decision making. C++14 introduced a type shortcut that uses both decal type and auto. Like all of our other examples for auto, this definition's data type comes from the type of the initialization value. However, the combined shortcut will use decal type's deduction rules instead of using auto's deduction rules. This code demonstrates one example where those two sets of deduction rules differ. Auto's rules would have chosen the most simple type possible, which would have been int. But the decal type rules say that this will be referenced to int instead.